Pascal's triangle and binomial expansion. Okay, so the next section that we're going to be talking about, the next topic is Pascal's triangle and binomial expansion. So Pascal's triangle, to generate Pascal's triangle, start with a 1 in the top row, and each new row starts with a 1 and ends with a 1. Then to find the numbers in the row, add the two numbers above. So again, every row starts and stops with a 1. So since there's only one spot here, it is 1. The second row, again, you're going to start with a 1 and end with a 1. So you get a 1 and a 1. In the next row, you're going to start with a 1. You're going to have a 1 on the other side. Okay, that's going to be true every single time. You're going to have 1s going down the first and the last section. And then we're going to take these two numbers, the two numbers above, and add them. So 1 plus 1 is 2. So now I'm going to take 1 and I'm going to end in 1. And to get the other numbers, I'm going to go 1 plus 2 is 3. 2 plus 1 is 3. And I'm going to continue doing this for the whole thing. So 1, 1, 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Again, start with a 1, end with a 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And you'll notice that we're getting symmetry here as we go across this. Okay, next one. Again, start with a 1, end with a 1. 1 plus 5 is 6. 5 plus 10, 15. 10 plus 10, 20. 10 plus 5, 15. 5 plus 1, 6. The last row here, and again, this can continue forever, but we're just going to stop with this row. We're going to start and stop with a 1. 1 plus 6 is 7. 6 plus 15 is 21. 15 plus 20 is 35. 20 plus 15 is 35. 15 plus 6 is 21. And 6 plus 1 is 7. And this is how you generate Pascal's triangle. Now, there's a lot of different relationships between the numbers here on Pascal's triangle. We're going to be looking at a couple of different ideas today. Now, just a little reminder, I had talked about this last time when we were doing combinations, that you can write a combination and choose R in this form, where you have the N on top and the R on bottom. And this is kind of another way to write and choose R. So the next thing I'd like for us to do is work out these different combinations. And again, this is really 0, choose 0, for example. This is 1, choose 1, 1, choose 0, 2, choose 2, 2, choose 1, 2, choose 0. So what you'll notice is every row is, for example, 4, choose 4, then 3, then 2, then 1, then 0. So we're going to compute these. Now we can put these in our calculator, but just couple little things just to kind of remember here. So if I have n choose n, okay, or n choose n like this, anytime I have n choose n, I'm asking how many different groups of n items can I get into groups of n? And that is always going to be a 1. So I don't care if it's 0, choose 0, 1, choose 1, 2, choose 2, and so on. That is always going to be a 1. Something else that we've talked about before, let me just kind of give an example. We talked about the following. Let's say I have 7, choose 4. We have seen that 7, choose 4 is the same as 7, choose 3. These two numbers add up to make the 7. So when I write this in the factorial form, on bottom, I'm going to have a 4 factorial and a 3 factorial. And I am also going to have the same over here. So these are always the same. So it's going to kind of help us get through this a little faster. Okay, so 0, choose 0 is 1. 1 choose 1 is 1. Now, in this case, 1 and 0 add up to 1. So these are going to be the same. So that's also a 1. Now I'm going to be dealing with my 2's here. 2 choose 2 is 1. Okay. 2 choose 0, because again, 0 and 2 add up to 2. So that's also going to be 1. They match up. Now, anytime I have, and let me add this one up here too, a number choose 1. So let me write it over here. N choose 1. This is asking us, how many groups of 1 can I get from n items? Well, if I want groups of 1 from n items, there's n different ways that I can have that happen. So no matter what number this is, whatever number this is, choose 1 is going to be this number every single time. So 2 choose 1 is 2. Okay, so now 3 choose 3 is 1, and 3 choose 0 is 1. Now 3 choose 1, we see is going to be 3, and then 1 and 2 add up, and these will also be 3. 4 choose 4 is 1, and 4 choose 0 is 1. 4 choose 1 is 4, and what goes with 4 choose 1? What's the same as 4 choose 1? 4 choose 3. And then if I'm doing 4 choose 2, let me get that in the calculator. 4 choose 2, 4 choose 2 is 6. So this is a 6. So now let's do this row here. 5 choose 5 is 1, and 5 choose 0 is 1. 5 choose 1 is going to be 5. And what matches with 5 choose 1? Well, 5 choose 4, so that's also going to be 5. Now let me see what 5 choose 3 is. So 5 choose 3. 5 choose 3 is 10. So I know that this is 10, but what matches with 5 choose 3? Well, 5 choose 3 is the same as 5 choose 2. So if you're looking at these numbers, you might recognize these numbers as the numbers that we got in Pascal's triangle. So again, let me turn the page for 1 sec. Pascal's triangle, we had 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And over here, you're going to notice we're getting those same numbers, 1, 5, 10, 10, 5, 1. So Pascal's triangle is really combinations. So when you're trying to figure out the combinations, let me just flip it one more time back. This number here, it's not what row it is, it's 1, 7, 1, 6, 1, 5. So if this is 1, 7, this is going to be our 7 choose, okay? Now, I personally like to start with this being 7 choose 7. Some books have us start with this being 7 choose 0, but I think I find it more helpful having this start with 7 choose 7 when I use this in other ideas like binomial expansion. So 7 choose 7, 7 choose 6, 7 choose 5, 7 choose 4, 7 choose 3, 7 choose 2, 7 choose 1, 7 choose 0. So again, this whole row is 7 choose 7 down to 7 choose 0. Okay? Okay. So here it says, what do you notice about Pascal's triangle and the combinations above? They are the same. They are the same. So basically your Pascal's triangle, each row is made up of combinations. Now, the next thing I'd like for us to do is work these out. So what we're going to do is we're going to be taking these binomials, a plus b, 2 terms, binomial. And I'm going to be taking a plus b to different powers. A plus b to the power 0 is 1, because anything to the power 0 is 1. A plus b to the power 1 is a plus b. Now, a plus b squared is a perfect square trinomial. And if you remember your formula for perfect square trinomial, you take your first one, square it, a squared. You multiply these together and double it. So that gives you 2ab. And you square the last term, b squared. So I have a 1, I have an a plus b, I have an a squared plus 2ab plus b squared. So now I'm going to flip the page. And I'm going to be looking at a plus b to the third. Now, when I do this, I'm going to think about it this way. I'm going to think about it as an a plus b times an a plus b squared. Okay, now we already worked out our a plus b squared. So really what I'm going to do is a plus b, and a plus b squared was a squared plus 2ab plus b squared. And I'm going to multiply this out. I'm going to use the box. And I'll put my a plus b over here. And I'm going to put my a squared plus 2ab plus b squared here. And I'm going to multiply all of these out. Let me just zoom in. So in this box here, I'm going to get a squared. Here, a times 2ab is a 2a squared b. A times b squared is an ab squared. B times a squared. I like to put my a's first. I like to do it in alphabetical order. That's how you see a lot of times in math. A squared times b. B times 2ab is 2ab squared. And b times b squared is b cubed. And then I'm going to combine like terms. So, and I'm sorry, this is not a squared. This is an a cubed. Okay. So again, a times a squared is a cubed. So now I'm going to combine these. So I'm going to get an a cubed plus, these are going to become a 3a squared b. These are going to become a 3ab squared. And then I get a b cubed. So now we're going to have to work this one out. Now, why am I having us do these problems? And on the same thing as Pascal's triangle and all these combinations. Well, I'm hoping that you start seeing a pattern here. And the pattern that I want you guys to notice is the coefficients in front of these. You'll notice that this is a 1, 3, 3, 1. You might recognize that from Pascal's triangle. Over here, this is a 1, 2, 1. Again, 1, 3, 3, 1, 1, 2, 1. This one right here is a 1 and a 1, and this is a 1. So these are the first rows of Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So I can use that idea to multiply out a plus b to the fourth. And so let's try that. So I'm going to be using this row, 1, 4, 6, 4, 1. Again, this one was when I had it raised to the power 0. This row is when I had it raised to the power 1. This row is when it's raised to the power 2. So I kind of think about these numbers here, 1, 2, 3, 4. So this would be a plus b to the power 4. So I'm going to come over here. I'm going to flip it over. And if you don't remember what the numbers are, just look at these numbers here. And remember, it's going to be a 1, add those together 4, add those together 6, add those together 4, and 1. And those are going to be the coefficients in front of your terms. Now, what you also want to pay attention to is you start with your a to the power out here, and then it goes down to 1, a to the 0. Your b's are going to go the other direction. This is your b to the 0, b to the first, b to the second, b to the third. Something else to pay attention to. This is a power of 3. 2 plus 1 gives you a power of 3 when you add them together. 1 and 2 makes 3, and 3. That will always be the case when you have just an A plus B. So let me start this off. So again, I'm going to be having 1 in front of my A, so that's going to be A to the 4th, plus, now I'm going to use this number 4. And then again, my A was a 4th, now it's going to be a 3rd. And then my B is going to be the 1 because these have to add up to the 4, plus 6. And again, A to the 4th, A to the 3rd, this would be A to the 2nd. And 2 plus what gets us 4? 2. Okay, and you'll notice that these are increasing, the B's, but that's how I kind of think about it. I start with my 4, 3, 3 plus what? 3 plus 1. Okay, 2, 2 plus what? 2 plus 2. Now my 4, A to the 1st, I'm going to write the 1 just so we see it there, B to the 3rd, and B to the 4th. And that's my answer. And I just multiplied this out. So this one here, again, I'm going to be kind of looking up at these numbers up here and doing what the next row is. I'm just going to write it here. I start with a 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And then a 1. So now I'm going to expand this. So again, I'm going to start with my A to the 5th plus 5, A to the 4th this time, B to the 1st, or again, just B, plus 10, A to the 3rd, and what adds with 3 to get 5? 2, so this is going to be a B to the 2nd, plus 10, A to the 2nd this time, so my B would be to the 3rd, plus 5, A to the 1st, which means my B is going to be B to the 4th, plus B to the 5th. And again, I just expanded that. So last one we would do is A plus B to the 6th. Okay, so again, similar method. I'm going to look at these numbers up here and figure out what the next row would be. So I'm going to start with a 1. These add up and give me a 6. These add to give me a 15, a 20, a 15, a 6, and a 1. So those are going to be the coefficients in front of these. So let me scooch it up. So I'm going to start with A to the 6th plus 6, A to the 5th, B to the 1st. And again, now my exponents are going to add up to 6 each time, plus 15, A to the 4th, B to the 2nd, plus 20, A to the 3rd, B to the 3rd, plus 15, A to the 2nd, B to the 4th. And let me write this down here since I'm kind of running out of space, plus 6, A to the 1st, B to the 5th, plus my last one is B to the 6th. And I just multiplied out this. So really this is A plus B times 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 A plus B. And instead of having to multiply that out, Pascal's triangle, which is just combinations, all of these coefficients are combinations, ends up giving us the answer. So now I'm going to switch to my composition book and I'm going to try an example where maybe it has a minus here and then where maybe we have something else besides an A and a B. So for example, let's say I have A minus B to the 4th. So the row I'm going to be doing is the row that's 1, 4. Okay, 1, 4. And if you cannot remember what that is, you can always refer back here. 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. And now what the difference is going to be, these are going to be the coefficients in front of each of my terms. And they're going to be multiplying with a to a powers. And here, this isn't going to be b, it's going to be a negative b to a power. So I'm going to start with an a to the fourth plus 4 times a to the third. And then it's going to be a negative b, okay, negative b to the first. Okay, so whatever is here is going to be raised to the starting power, and it's going to keep going down. And then here, including the sign, that's what's going to go here, and that's what's going to be raised to the other power. So I'm going to continue plus 6. And again, it was a to the third, so this is going to be a to the second. And again, it's going to be a negative b to the second, because 2 plus 2 is 4. And 4. A to the first, so negative b to the third, and negative b to the fourth. Now what you're going to notice is going to happen is a negative to an odd is a negative. A negative raised to an even is a positive. So this is going to be positive, negative, positive, negative, positive. You're going to get alternating signs here. So my final answer, a to the fourth minus 4a to the third b plus 6a squared b squared. And again, this one's going to be minus 4a b to the third plus b to the fourth. Okay, again, anytime it's a negative to an even, it's going to be positive, and negative to an odd, it's going to be negative. And that's your answer. So now let's try one where we have maybe not just a plain A or B, maybe we have a coefficient in front of those. So I'm going to switch up the letters too. So let's say we have the following. Let's say we have 2x plus 3y to the third. Okay. So I'm going to be using the row that is 1, 3. Okay. So again, that row is the row that's 1, 3, 3, 1. That's the row I'm going to be using. 1, 3, 3, 1. 3 choose 3, 3 choose 2, 3 choose 1, 3 choose 0. So now I'm going to take this 1, okay, and I'm just going to write the 1 just to, 1 is going to times with this 2x to the third power, okay, plus 3, and I'm going to have 2x now to the second, and this term is a 3y, so I'm taking my 3y to the first. So I'm going to be raising 2x to powers and 3y to powers. Plus 3, and again, I went 2x to the third, 2x, and that one was squared, so this is going to be 2x raised to the first, 3y to the second, plus 1 times 3y to the third. So now we're going to work this out. Now understand, this is not 2x to the third, this is 2x raised to the third. So 2 to the third, this gives me an 8, 8x to the third. Now here, this is a 3. 2 squared is 4 times 3. So 3 times 4 is 12 times 3 is 36. X to the second, y. This one here, 3 times 2, because this is 2 to the first, times 9. This is a 9. So 3 times 2 is 6. 6 times 9 is 54. So this is going to be a 54xy squared. Over here, this is a 3 to the third. So that's going to be a 27y to the third. And we just multiply it out, 2x plus 3y to the third. Okay, so last one. I'm going to try another one. I'm going to put a negative in, and I'm just going to use a 3 and a 2 again, just to make it a little simpler numbers. So let's say it's a 3x minus 2y this time, raised to the power 4. So again, since it's a 4, I'm going to be using the next row after this, which would be 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. So again, I'm going to take my 3x. It's going to be raised to the 4th. And then I'm going to be raising a negative 2y to powers also, okay? Plus 4 times 3x to the 3rd. And my negative 2y is going to be to a 1 because these need to add up to 4. Plus 6 times 3x to the 2nd this time, which means my negative 2y will be to the 2nd because 2 and 2 add up to 4. Always trying to get this number. Plus 4 times 3x to the 1st and negative 2y to the 3rd and plus negative 2y to the 4th. Okay, now what's going to happen again is it's going to be alternating signs. A negative to an odd is negative. This negative being squared is a positive. Negative to the 3rd is negative, and negative to the 4th is positive. So here I have 3 to the 4th, which is 81. So this is 81x to the 4th. Now here, just to show you, you guys could just put the numbers in your calculator if you don't want to do all of that in your head. Now when I'm saying the numbers, I have a 4 times a 3 to the 3rd, which is a 27, times a negative 2, and I end up getting a negative 216. So it's going to be minus 216 x to the 3rd y. Now this one's going to be positive, okay? And this time I have 6 times 3 squared, which is 9, times a negative 2 squared, which is 4. So I end up with a 216, okay? A 216 x to the 2nd, y to the 2nd. Now the next one is going to be a minus, okay, because it's going to be a negative to an odd power. And I have 4 times 3 times negative 2 to the 3rd, and that's going to give me a negative 96. So it's a minus 96 x y to the 3rd. And then here a negative 2 to the 4th is a 16. So I have a 16y to the 4th. And that's your answer. And again, I know this looks like a little bit of effort, but it's much easier than taking 3x minus 2y, 3x minus 2y, 3x minus 2y, 3x minus 2y, and multiplying it out. I think it's a little faster. And that's the end of our notes for today.